We're going to look at this acceleration of the moon problem. We're going to look at an example of how we can compare two problems without having to plug numbers in. It's a good technique in physics. So the comparison that we're getting here is that the acceleration due to gravity on Earth is our good old g. The acceleration of gravity due to the moon is 1/6 of what it is on Earth, or g divided by 6. And so we want to figure out how height relates to this constant between the two different bodies, the Earth and the Moon. So we're assuming they have the same initial velocity, and they're going to go to a maximum height where the velocity is 0. So we can look at the final velocity is equal to vi, which is going to be the same, squared plus 2a delta x, which in this case is the height. I'll call it height. And so we're going to solve this equation knowing that this goes to 0. We're going to solve it for h. So we get 2ah equals vi squared with a negative sign here. And then we're going to get h equals vi squared over negative 2a. Now this is going to be the same equation for the Earth or the Moon. The only difference is a. We've already said vi was the same. So we're going to compare the height on the Earth, he, equals vi squared over negative 2ae, the acceleration due to gravity on the Earth, and the height on the Moon, which is vi squared over negative 2am. We're going to compare these two equations. Let's divide them by each other. So we'll get he divided by hm. Let me scroll this up so we can see it here. All right, he divided by hm equals vi squared over negative 2a on the Earth divided by hm of the Moon, vi squared over negative 2am. Now what's nice about a comparison like this is the vi's we said were the same, so they'll cancel on either side of my fraction, and the negative 2's cancel. And so what we're left with is the height of the Earth, the height this object will go when thrown from the Earth, and the height on the Moon is 1 over ae. Well, ae was g. And then in this bottom section here is 1 over 1/6 g. So we've got a lot of complex fractions here, but we'll use our rules of reciprocals. So, and we want to solve for the height on the Moon. So let's see how our reciprocals will help us. We've got a lot of division going on, but let's just clean up these ratios. We haven't had to do any complex mathematics, and we're just doing a comparison here. So he over hm equals, and so these g's cancel because they're both in the denominator, and this becomes 1 upstairs because the g's cancel, and the g canceling here gives 1 over 1/6, or 6 in the denominator. Alright, so we'll cross multiply, and so hm equals 6 times. And so the height this object will go when thrown with the same velocity on the Earth versus on the Moon is 6 times what it would do on Earth. And ratios are a good way of comparison, especially if our equations give us the same variables. And so if we see two equations with the same variables, instead of plugging in numbers and doing comparison, we can take ratios. And a key for that in a lot of problems is when you see how many times. That really is asking for a ratio out of it all.